I'm Jane. I work on PyTorch from Meta, and today I'd like to motivate why we want a stable limited LibTorch ABI and how we plan on doing it. Cool. So let's start with where we started. If we imagine LibTorch as a binary blob where, ABIs, where all those little pointy bits are where our dependencies sit on top of us, then you can imagine the world like a stack of libraries that sit on top of LibTorch. And the problem with this is whenever we upgrade LibTorch, the ABI is not guaranteed to be the same, so everything in the world or everything in the stack would also need to upgrade. Oh no. So if only everything was, a nice box where you can just swap out the boxes and the rest of the stack could stay exactly the same. In that case, you can upgrade LibTorch however you want because, everything's flat, you can be v2, you can be v3, it's great, except we can't actually do this. And in fact, we don't really want this because what this would mean is we would need to freeze every API in our library. And that's not a good plan. Nobody wants this. We want to continue improving, growing, fixing those bugs that we didn't realize we had before. So what do? Well, that's where we have the limited ABI. What if we built a stable subset of ABIs that extensions can rely on? So if you sit on this flat portion of LibTorch, we promise you that even if we upgrade, you don't need to rebuild your extension. Concretely, what would it take to, have Flash Attention 3 be LibTorch ABI stable? And that's where we gotta ask ourselves, why is it not stable in the first place? Like, what APIs is it using that are currently unstable? And these APIs should be really familiar to most people. Tensor, if you're a custom op writer, you care about registering to Torch library. You probably care about A10 ops, like calling pad or fill or mapmul. The device utils, if you're writing a CUDA kernel, you care about CUDA events, CUDA guards. And lastly, all those little things that you might not think about, like bfloat16, the scalar types, those are all APIs that live in LibTorch today that are not guaranteed to be stable. So our plan is to pave a path, and we literally mean that. Like, we literally mean to steamroll a C shim that would sit on top of this unstable API and provide a surface that extensions could rely on without having to be broken every time. And what that concretely means is actually literally having, for example, for Tensor, having a shim API that it would liaison between the unstable Tensor API and the user itself. And if you're wondering what magic this is, it's actually not that magical. We just, instead of passing a big tensor around, we pass around a pointer. And thanks to AOTI, the compiler team, we already have that. So A10 tensor handle is just an opaque tensor pointer. And what you would do with that pointer is pass it into other AOTI functions that are also promised to be stable already. If you think about this just for a little bit, you can imagine that this is not a pretty API to work with. You are working with pointers everywhere. Everything is in a C-style API. For example, this 1 line, or I guess 3-line change becomes 10 lines because, for example, you see in line 242, you allocate in a 10 tensor, which is a pointer. You pass that pointer into 247, and by the end of that call, you're kind of guaranteed that, out will now be some tensor that is representative of all the things you wanted. If you're curious, like I thought the C shim might have been feasible at first as well, and I tried it, but it is very ugly, and you can look at that link if you want to look at how ugly this truly is. So how can we make this not ugly? With UX in mind, we decided that, hey, maybe the C shim is not what custom ops writers want to use. Maybe they still like C++. So we're like, okay, let's give them C++. So we introduce Torch stable tensor, which sits on top of just the stable portions, on top of the shim APIs, and therefore is guaranteed to be ABI stable as well. The actual C++ API is not shim stable, but it promises to only use the shim APIs, and you can imagine it just wraps around this pointer and works all of that logic out for you. And one thing you might also realize is that memory is really hard when you're just passing around pointers everywhere. So Torch stable tensor would also work that out for you as well. And with that, instead of having it go from 3 lines to 10 lines, you can actually write the same code in 2 lines, which I think is a lot cleaner. Cool, so let's move on. What is next? Well, what about Torch library impl? If you maintain your own custom op, you probably, this call should be very familiar to you. Every op you write, you need to register the schema to the Torch dispatcher. And it's the same drill. We add a shim version of Torch library impl, and then we add a nice macro on top of it so that your user experience could be similar. But the challenge here is all these schemas, like forward, backward, forward combined, they all have different schemas. How do we make all these different schemas fit under one AOTI Torch library impl C shim call? So if you've read if you know about I values, you already know the answer. We use the same idea behind box kernels. So instead of passing around like tensor, wait, what was it? Tensor, optional scalar type that returns two tensors, we actually just convert every one of those args into an I value, a stable I value for us. And so instead of passing a different schema everywhere, everything just gets reduced to a stack of stable I values, also named stable I values. We're still working on support for what I values are supported, but check out our docs for what's currently supported. We're actively working on this, so be on the lookout. Okay, moving on. What about A10 ops? Same drill. You add, for example, fill, you add a shim for fill, and then you add the C++ API on top of fill, and we're done, right? Well, not quite. If you think about it, there are like 2,000 A10 ops. We don't really want to add 2,000 shims to our ABI. So we introduced this new call called AOTI Torch Call Dispatcher. And this is when I realized that we should probably stop naming things after AOTI, so you can ignore that part. But this one API is really cool because it reuses the idea that, hey, if everything already goes through the dispatcher, we can reuse the dispatcher, pass in a schema for whatever A10 op you want, and get support for it with just one API. So you see here, instead of having, I don't know, five A10 ops represented with 5 shim APIs, there's just one. We don't need more. All right. The next thing here, like device, of course, so for like CUDA event or CUDA guard, it's the same drill actually. You add a handle in the shim, which is a pointer, and then you add some nice convenient C++ wrappers on top of that. This one is very nice. Great, done. So do we do the same thing though for A10 half? For utilities like bfloat16 or all these other things? Do we just add, do we also steamroll and pave with a shim? Well, actually, no. So this is when we realize that half is already implemented in a header-only way. And what that means is that the implementation for half lives entirely in a header itself. And if you note here, this means that the header, those APIs have no dependence on LibTorch already. Okay, so for all of those APIs, we're formalizing a Torch header-only namespace where it's a namespace you can trust to have APIs that do not depend on LibTorch. And we wrote tests for this, so you can, that's a guarantee for you. And half now lives there. You can still call half through A10 half, like we're not BC breaking anyone, but use Torch header-only stuff if you want those guarantees. So if we put it all together, what does the new LibTorch look like? And this is, I think, where we should pause and absorb like this entire frame. So you still have your old LibTorch that is subject to change. Those spiky bits can move for every release. But we're deciding that, hey, we want this C shim that sits on top of those spiky points that are promised to be flat and smooth so that you can depend on it each time. But we realized that the C shim is not good UX. So we decided to build a high-level convenience wrapper living in Torch C-source stable that promised to only use those stable APIs. And then separately, independently from all of that, we have our Torch header APIs that guarantee no LibTorch dependency at all. Okay, what does that mean? Well, it means that we can actually just migrate Flash Attention 3 from the unstable portion onto this new, more stable stack. And 2 things to note here. 1, Flash Attention now sits directly on the flat portion. That guarantees that it can be ABI stable. But because of our convenience wrappers, note that we don't actually have to change much about Flash Attention 3 to get it to be API stable at all. And the note here is that much is a little subjective. If you're curious what that actually looked like, check out Michaela's PR. Big props to Michaela for implementing a lot of the features mentioned in this talk. And if you're also curious about, hey, is this Flash Attention 3 wheel really stable? You can try it yourself. We're actually hosting this wheel just for our CI, but why not? It's already public, it's read-only. You can download it, you can play with it. Let us know what goes wrong. Just for details, it's built on a nightly, and it should, with CUDA 12.9, and it should work with any torch after 2.9. Yeah, so we're still working on this. Like Flash Attention 3 was just the first step, but what can you do? What am I doing? Well, you can start using those APIs today. As you can see, a lot of the things that are used across all custom ops are already supported. So please use them. Let us know what's weird. Let us know what APIs you'd like to see. We're continuously working on this. We're always increasing more APIs. We're always shaping up what that looks like. And one other super cool thing we're working on is being able to target a lower or a different API version than the one you're building with Torch target version. And as always, we are working on more docs and tutorials so that you don't have to ask me questions after this conference. Anyway, thank you for your attention. Does anyone have any questions? How much time do I have? Oh, I have no minutes. Oh, but I don't think there's a talk after this, so go for it.
I have a question about build system. Do you have plan to have a saving any system so that you will deal with set up which are
So the question is, are we going to promote a CMake build system for like C++ extensions? You could technically use CMake with the C++ extensions today, but I think there's a way to work around it like that, but I'm not super familiar with concretely what you want to do, but I think a lot of what you want should be doable already.